Welcome to Fulcrum Intel Digest. This is Season 1, Episode 18. Today we are diving deep into a topic that's really at the sharp end, where advanced tech meets high-stakes conflict. We're looking at how artificial intelligence is being deployed, or at least proposed, to tackle the incredibly dynamic and asymmetrical threat of insurgency in the Sahel. And we're focusing particularly on the situation in Burkina Faso. Now, our mission today, as always, is to give you a real shortcut to understanding this complex issue. We've gone through the expert source material that outlines the crisis, looks at why traditional military responses are, frankly, struggling, details these cutting-edge AI solutions, and maybe most importantly, digs into the huge operational and ethical challenges that come with them. And hey, if you appreciate getting this kind of analysis, this quick, thorough knowledge drop right into your feed, please take just a second right now, hit that subscribe button, and give this deep dive a like. It honestly makes a big difference and helps us keep bringing this content to you.
It really does.
So we often talk about AI, maybe in business or between superpowers, kind of abstractly. But this is, well, this is where it gets very real. Counterterrorism scenarios. Life and death decisions potentially influenced by algorithms. As we set the stage here, looking at the source material, what's the most immediate thing that jumps out about the current crisis?
Well, I think the most striking point really is the sheer inadequacy of conventional counterinsurgency tactics against this kind of threat. What's happening in the Sahel, and especially in Burkina Faso, it's not just a localized rebellion. It's this complex transnational wave of instability, and it demands more than just new gadgets. It needs a completely different way of thinking about intelligence.
Right.
The old ways, large patrols, fixed bases, they're just not working against an enemy that thrives on speed and surprise.
Okay, so let's unpack that operational environment. Part 1, the Sahelian crucible.
To really get why AI is even on the table, you have to go back to the root cause. The sources, they pretty consistently point to 2011, specifically the collapse of state control in Libya.
Yeah, that feels like such a pivotal moment for the entire region, looking back.
It absolutely was. It wasn't just a power vacuum. It was like opening the floodgates. You had this massive outflow of sophisticated weapons. We're talking anti-aircraft missiles, heavy machine guns and fighters, experienced combatants moving south.
Into those areas with very little governance.
Exactly, into the Sahel's porous, ungoverned spaces. And this injection of, hardware and expertise, it basically supercharged existing tensions. It gave a huge boost to emerging groups, empowered organizations like Jainim Jama at Nusrat al-Islam, Wal Muslimin, and ISGS, the Islamic State in the Greater Sahara.
So less of an internal slow burn and more like a sudden external shock that then metastasized into a domestic crisis within countries like Burkina Faso.
That's a good way to put it. It definitely spilled over. Started more in Mali, but by 2015 it was clearly a domestic crisis in Burkina Faso too. Initially the violence was more targeted, focused on the capital, Ouagadougou.
What was the aim there? Not holding ground, presumably?
Not primarily, no. The goals seem to be economic disruption hitting tourism, mining logistics, and maybe more importantly, undermining public morale, shaking faith in the state's ability to provide security.
That psychological aspect is key in insurgency.
It is, and it worked, to a degree. But as the government tried to respond, the insurgency shifted tactics. It spread out into a more generalized rural conflict. They exploited the vast distances, the weak government presence outside the cities. And it really defines the adversary today. They're transnational, they're fluid, they adapt.
Meaning they often run rings around traditional military forces designed for more conventional fights.
Precisely. Which brings us squarely to the challenges for those traditional forces. It's asymmetric warfare 101.
What are the insurgents' biggest advantages on the ground? Geography must be one.
Huge. Geography is number one.
Yeah.
They use these enormous, often ungoverned border regions. The tri-border area is infamous, especially the borders with Mali and Niger. They're incredibly porous.
Allowing them to do what? Stage attacks and just melt away?
Exactly. Stage complex operations, conduct attacks, and then simply retreat across a border to refit, regroup, and plan the next move without facing sustained pressure.
And tactically, it's not just one type of attack, is it?
No, it's very much what the sources call hybrid warfare. It's a mix. You see conventional ambushes on military convoys, direct assaults on fixed military bases, but also classic terrorist tactics aimed squarely at civilians or at the infrastructure of government schools, local government offices.
Undermining the state from all angles.
Right. It makes it incredibly hard for the state to project control and legitimacy at the same time.
Which leads to what seems like the core vulnerability for the security forces. The intelligence shortfall. Old methods chasing a hyper-mobile enemy.
It's the crux of it. The critical weakness is the lack of integrated intelligence. Current systems are often stovepiped. Data from one unit or one type of sensor doesn't easily connect with others.
So you can't do that deep pattern of life analysis, tracking subtle changes over time.
Very difficult. And it prevents the creation of a truly unified common operational picture, a COP, everyone seeing a different piece of the puzzle.
And without that integrated view, commanders are constantly reacting, facing tactical surprise.
Constantly. They're always a step behind. And this inability to connect the dots, the phone intercept in town A with the supply movement near village B, means decisions are made with incomplete information.
Which leads to this dangerous paradox the research highlights, the problem with reactive measures.
Yes. When forces are surprised, the response is often heavy-handed. Large-scale operations, maybe airstrikes, these might provide temporary relief in one area.
But the collateral damage.
Exactly. The collateral damage can be massive. And every civilian casualty, every damaged home or marketplace,
It's recruitment fuel for the insurgents.
instantly. It's weaponized for propaganda. The narrative becomes the state is clumsy, indiscriminate, maybe even foreign-backed and hostile. This erodes public trust, which is vital. And critically, it dries up human intelligence, human aid. People become afraid or unwilling to talk to the security forces.
Creating a vacuum the insurgents are happy to fill?
Precisely.
Yeah.
They step in, offering their own form of governance or justice or security. It becomes a vicious, self-feeding cycle.
Okay, so the situation is feeding itself. The imperative then, as the sources argue, has to be shifting from just collecting data after the fact to actively generating foresight, getting ahead of the enemy's decision cycle.
That's the only way to break the cycle.
Yeah.
You have to move from descriptive intelligence, what happened, to prescriptive intelligence, what's likely to happen, and how can we shape it.
Which is where the AI toolkit comes in, transitioning to prescriptive insight.
Yes. This is the core mission proposed for AI-driven predictive analytics here, to make that leap. Using advanced machine learning to find those hidden, subtle patterns in vast, noisy data sets that humans alone just can't process effectively or quickly enough.
So what kind of data needs to feed these models? What's in this multidimensional stack they talk about?
Well, models are hungry. They need a fusion of different inputs. You start with historical attack logs, obviously locations, times, methods.
Standard stuff.
Standard, but essential baseline. Then you need to layer on signals intelligence, SIGINT, tracking communications, electronic emissions, phones, radios, data bursts.
Seeing the unseen electronic activity?
Right. Then geospatial intelligence, GeoINT, that's your drone footage, satellite imagery, terrain analysis, mapping changes over time.
And crucially, the human element. Human.
Yes, but that's often the trickiest. Integrating potentially sensitive, sometimes narrative-based human reports into a system that also processes numerical coordinates and pixel data. The big challenge is making sure these different data types can actually talk to each other within the model, that they're standardized and usable.
Okay, let's get into the algorithms themselves. The sources mention some specific powerful tools, starting with spatiotemporal pattern analysis, the where and when predictor.
This is where you see things like deep learning models, specifically TabNet is mentioned. It's a tabular deep neural network architecture. It's often used alongside strategic frameworks like effects-based operations, or EBO. TabNet is apparently quite good at handling the kind of messy, mixed data you get in a conflict zone. Some data is numerical, like coordinates, some is categorical, like time of day, weather conditions, type of terrain.
So it can process all that mixed input. How does it help a commander? What's the output?
Its purpose is really high-level forecasting. It's designed to find complex, non-linear relationships. Things a simple trend analysis would miss. For instance, it might flag that attacks are, say, 75% more likely in a specific area on market days, but only when it follows a certain pattern of reconnaissance activity observed via drone, and if a particular Allied patrol hasn't been through in the last 48 hours.
So it connects multiple, seemingly unrelated factors.
Exactly. It forecasts the confluence of vulnerabilities. The output is often visualized as a dynamic predictive map.
Like a heat map showing probable hotspots.
Sort of, yeah. Probabilistic terrain maps, color-coded to show where insurgent activity is most likely in the near future, say the next 24-72 hours. It shifts intel from here's what happened to here's where you should focus your attention next.
That's predicting the where. But what about the how, predicting the likely method of attack?
For that, the sources point to optimized ensemble classifiers. Think of these as combining the predictions of several different machine learning models to get a more robust answer.
Safety in numbers, algorithmically speaking?
Kind of, yeah. Examples mentioned are particle swarm optimization, PSO, used perhaps to tune the models, and then classifiers like random forest and XGBoost extreme gradient boosting.
Okay, and their job is?
Their job is to improve the accuracy of classifying the type of attack predicted. They analyze features from past incidents, the signature of the attack, vehicles used, proximity to known smuggling routes, things like that.
And knowing the likely type helps how?
It allows for tailored preparation. If the system predicts a high probability of an IED emplacement team operating along a certain road, you send EOD assets. If it predicts a complex ambush with RPGs, you might adjust patrol composition or use aerial overwatch differently. Preemptive defense tailored to the specific predicted threat.
Makes sense. But the threat isn't just isolated attacks, it's an organized network. Which brings us to social network analysis, SNA.
Right. SNA is absolutely critical for understanding the enemy as a system, not just a collection of fighters. It's about fusing communication data, financial transaction data, human reporting on relationships to map out the structure. You define the nodes, the key people.
Like leaders, financiers, recruiters.
Exactly. Or even facilitators like sympathetic elders or logistics guys.
Yeah.
And then you map the edges, the connections between them. Shared phone contacts, money transfers, family ties, even just observed meetings or use of the same resources.
So it literally draws a map of the insurgent organization.
It aims to, yes. A graph showing who's connected to whom and how strongly. The purpose here is identifying and prioritizing high-value targets, HVTs, but not just the trigger pullers. By mapping the network, the system can highlight the critical logistical nodes, the key financial conduits, the propaganda leaders, the people whose removal would cause the most disruption to the entire network.
Shifting the focus from simple attrition
to targeted network disruption.
Yeah.
Hitting the command and control, the logistics, the finances, to make the whole organization less effective, more brittle.
That's quite a strategic shift. The sources also mention something almost humanitarian. Predictive logistics for managing attack aftermaths.
Yeah, this is a fascinating application. It uses deep neural networks, DNNs, and gradient boosting regression models. So when the system predicts a likely attack in a certain area with a certain method, it doesn't just warn forces, it also tries to estimate the outcome.
Like the potential number and type of casualties.
Exactly. Anticipating the scale and nature of mass casualty incidents, MCIs, and that foresight allows for proactive resource positioning. If it predicts an attack likely to cause significant blast trauma, maybe it suggests pre-positioning specific medical supplies or surgical teams closer to that area.
Or planning evacuation routes?
Determining optimal aeromedical evacuation corridors before an incident happens, ensuring the right type of blood supplies are nearby. It's about shrinking that critical golden hour for trauma care by anticipating the need.
Incredible potential there. Now, across all these models, the sources emphasize a technical safeguard, SEMOT. Synthetic minority oversampling technique. Why is this so important in this context?
It addresses a fundamental problem with conflict data. It's usually highly imbalanced.
Meaning
Meaning you have a ton of data points for frequent, maybe lower impact events, small arms fire exchanges, minor roadside IEDs that don't cause casualties, routine patrol sightings.
Okay.
But the really critical high impact events, a large-scale coordinated attack, a successful assassination, a major bombing, these are statistically much rarer.
Right, they happen less often.
So if you trained an AI model on this raw, imbalanced data, it learns really well how to predict the common stuff. But it might start to ignore or underpredict the rare, high-impact events simply because it hasn't seen enough examples in the training data.
So the model becomes biased towards the frequent noise and misses the critical signals.
That's the risk. SMOD is a technique designed to counteract that. It works by synthetically creating new artificial examples of those minority class events, the rare but important ones.
It generates fake examples of major attacks to make sure the AI learns to recognize their precursors.
In essence, yes. It balances the dataset during training, so the model doesn't become complacent about rare but catastrophic possibilities. It ensures those infrequent but crucial events get enough weight in the model's learning process.
That sounds clever, but also potentially tricky. Adding synthetic data to a system guiding real-world actions.
Absolutely. There's a definite trade-off. While SEMOT helps mitigate that frequency bias, introducing synthetic data always carries the risk of generating false positives.
Ghost targets.
Ghost targets, phantom threats. The AI might flag something based on patterns learned from synthetic data that isn't actually materializing. This could waste resources, divert attention, or, in the worst case, contribute to wrong decisions.
Which underscores the need for human judgment somewhere in the loop.
Critically, you need human analysts, commanders, validating these outputs, especially when techniques like SMODI are involved. It's a tool, not an oracle.
Okay, so that's the toolkit. Let's talk about how this actually changes operations. Part 3. Applications and the concept of operations, cone OPS. The sources stress this really speeds up the OD loop. Observe, orient, decide, act. How does AI help compress that cycle?
Well, the OD loop is all about decision speed, right? Getting inside the enemy cycle. AI acts like a massive accelerator, particularly on the observe and orient phases. Instead of analysts manually sifting through mountains of raw data, the AI does that initial heavy lifting, observing patterns, fusing information, assessing risks.
So it presents the commander with a pre-digested picture.
Exactly. A refined analysis, the orientation piece. This allows the commander to move much faster, to decide and act, hopefully with better situational awareness than the adversary. They react quicker, potentially seizing the initiative.
And what does this look like practically? For a commander in a tactical operations center, how does this AI stack actually appear?
It often manifests as this dynamic common operational picture, the DCOP we mentioned. But think of it less as a static map and more as a living, breathing visualization of the battle space. The AI is constantly churning in the background, updating predictions, highlighting emerging threats, analyzing new intel feeds, SIGINT, joint, HUMANT, and integrating it all into this ongoing intelligence preparation of the operational environment.
And the benefit of having this dynamic picture saves time, resources.
Both, significantly. First, resource allocation becomes much more efficient. Instead of sending out broad ISR patrols hoping to find something.
Intelligence, surveillance, reconnaissance.
Right. Instead of those wide sweeps, the DC COP allows commanders to focus assets on specific high-probability missions identified by the AI, like investigating a suspected weapons cache pinpointed by the system, or interdicting a supply route flagged as unusually active.
More like surgical strikes than area bombing, informationally speaking.
That's a good analogy. It allows for tactical precision, less wasted effort, less time delay, potentially fewer assets put at risk on unproductive tasks.
And this precision naturally flows into targeting, right? Making it more accurate, more effective.
Yes, the SNA and the spatiotemporal analysis directly feed into better targeting by identifying those critical HVTs and key network nodes with higher confidence.
It enables genuine precision targeting. And you mentioned effects-based operations, EBO.
Right. EBO focuses on achieving specific effects to cripple the adversary system, rather than just focusing on body counts or destroying equipment. So the AI might help identify that disrupting a specific logistical coordinator, maybe through a non-kinetic means like freezing their finances if possible, or a very precise kinetic strike, would have a far greater impact on the insurgent network's ability to operate than, say, engaging in a risky firefight with a random foot patrol, which might cause more collateral damage anyway.
So it's about systemic disruption, not just physical destruction.
That's the idea. Making the enemy system fail.
Does the AI only help with kinetic options? Or can it guide other forms of pressure?
No, it's crucial for integrating multi-domain challenges. The AI can assess vulnerabilities that might be exploited through non-kinetic means. Think psychological operations, PSYOPs, identifying populations receptive to certain messages, or cyber actions disrupting communications networks, maybe interfering with online recruitment or propaganda dissemination.
It's fighting across all fronts simultaneously.
Exactly. Kinetic, cyber, information, the AI, helps orchestrate actions across these domains for maximum effect.
And that information domain, information operations, IO, is so vital in counterinsurgency, where legitimacy is key. How does AI help win the narrative war?
It can be a powerful tool for IO. By analyzing open-source data, social media trends, local news reporting, even sentiment in specific dialects used on messaging apps. The AI can track how insurgent propaganda is spreading. For example, if there's a false claim circulating about state forces committing an atrocity.
Which happens constantly.
All the time. The AI can help identify the key influencers or channels spreading that message most effectively. This allows the government or allied forces to respond much faster and more precisely with tailored counter-narratives, using credible information targeted at the specific audiences being influenced. It helps build and maintain state legitimacy by being responsive and accurate.
It's like an early warning system for misinformation campaigns.
And a guidance system for counter-messaging.
Finally, and maybe most importantly for the soldiers involved, what about force protection?
This is a huge potential benefit. The AI can generate dynamic, near real-time threat assessments for friendly forces. It can analyze patrol routes, assess the security of fixed bases, identify areas where IED risk is suddenly elevated based on patterns only the AI might detect, unusual traffic, specific SIGINT chatter, correlations with historical data.
Proactive risk management.
Exactly. Proactive risk management informed by predictive analytics. The clear goal here is fewer casualties for friendly forces and improved overall operational efficiency. That's critical for maintaining morale and, frankly, political will for these long-term missions.
Okay, the potential benefits are clearly immense, but the sources are also very clear about the dangers. Part 4. Challenges, critical limitations, and ethical risks.
And this is where we need to be incredibly careful. The potential is huge, but the pitfalls, especially when deploying this technology in lethal environments, are profound. We have to shift gears from capability to constraints.
Right. And the absolute foundation, the problem that affects everything else, is data quality and integrity. That old saying, garbage in, garbage out. What does garbage look like in the Sahel context?
Oh, it looks like a lot of things. First, just inconsistent reporting, different units, different partner forces from the G5 Sahel countries, maybe even different agencies within one country. They might all be logging incidents using different formats, different standards, different levels of detail, even different languages sometimes. Trying to merge that into a single usable data set is a nightmare.
Incompatible data.
Highly incompatible. Then you have the issue of inherent biases within the historical data itself, which we need to talk more about.
Okay.
And finally, just poor mechanisms for standardized, secure data sharing between partners. There might be political hurdles, technical hurdles, trust issues. So the data feeding the AI might be messy, incomplete, biased, and potentially insecure right from the start.
And if the input is bad, the output can be catastrophic.
Absolutely. Flawed data leads to flawed predictions. An algorithm-fed bad data could give tactical advice that sends troops into an ambush they should have avoided. Or, even worse, it could contribute to misidentifying civilians as combatants, leading to tragic consequences. Data integrity isn't just a technical issue. It's the bedrock of safe and effective operation. It's the single point of failure.
Which leads directly into the next major risk, algorithmic bias. The sources specifically flagged the danger related to ethnicity, mentioning the Fulani people. This isn't just bad data, it's biased data creating discriminatory outcomes.
This is arguably the most dangerous trap, both operationally and ethically. Counterinsurgency often relies heavily on intelligence gathering within specific communities. Now, if the historical data used to train the AI reflects past biases, maybe security forces historically focused more attention, conducted more arrests, or had more hostile encounters in areas predominantly populated by a certain group, like the Fulani.
The AI learns that pattern.
It learns that pattern, and worse, it can institutionalize and scale that bias. The model might start to correlate ethnicity or location with insurgent activity, simply because that's what the biased historical data showed. It stops analyzing suspicious behavior and starts flagging suspicious identity or location based on past, potentially discriminatory policing or military practices.
And if an AI starts recommending actions based on ethnic profiling, essentially?
The consequences are devastating. Operationally, you get bad intelligence, potentially leading to wrongful detentions or targeting, violating fundamental principles of distinction under IHL.
International humanitarian law.
Right. But the sociopolitical fallout is even worse. If the state or its allies are seen to be using AI that systematically targets a specific ethnic group, it validates the insurgents' primary propaganda narrative, that the government is persecuting them based on their identity.
It destroys trust completely.
Utterly. It sacrifices community relations, cuts off vital human, and hands the adversary an enormous propaganda victory. It undermines the entire counterinsurgency effort, potentially fueling the conflict it's supposed to help resolve.
So besides the system potentially harming itself through bad data or bias, what about the enemy actively attacking the system? The fog of data idea.
Right. A sophisticated adversary won't just fight kinetically. They'll fight in the information space, targeting the AI itself. They can employ data poisoning, deliberately feeding false or misleading information into channels they know or suspect are being monitored, subtly corrupting the data over time to degrade the AI's accuracy.
Making the predictions unreliable.
Exactly. Or they could launch complex misinformation campaigns specifically designed to trigger false alarms from the AI.
Sending forces on wild goose chases.
Wasting time, fuel, resources, maybe even luring forces into ambushes by making them react to phantom threats generated by the AI. The goal is to create so much noise and uncertainty that commanders lose faith in the system's outputs, effectively blinding them again.
Crippling that OODA loop advantage we talked about.
Precisely, turning the technology against itself.
And then there's the huge legal and ethical cloud hanging over all of this. The lack of clear rules, the legal vacuum around using AI for lethal actions, particularly regarding IHL.
This is a massive strategic risk, and it's being debated intensely right now. IHL requires adherence to principles like distinction telling combatants from civilians and proportionality ensuring attacks aren't expected to cause excessive civilian harm.
How does AI complicate that?
Well, if the AI is involved in identifying targets or predicting collateral damage, how do you ensure compliance? If the AI's target profile is based on flawed data or bias, is the principle of distinction violated even if the human operator thinks they're hitting a valid target? If the AI calculates predicted collateral damage, but its model is incomplete or wrong, leading to excessive harm, who failed the proportionality test?
And the ultimate question, who is responsible if the AI gets it wrong and people die?
That's the core of the legal vacuum. Is it the human operator on the ground who pulled the trigger based on the AI's recommendation?
Or the programmer who wrote the code?
Or the data scientist who curated the training data? Or the commander who authorized the use of the system under potentially ambiguous rules of engagement? ROE.
There's no clear answer right now.
No widely accepted legal framework exists yet. This ambiguity creates significant legal risks for military personnel and political risks for the nations deploying these systems. It undermines operational legitimacy.
And this is made worse by the idea of human in the loop, HITL, maybe not being effective.
That's a serious concern raised in the sources. If the AI processes information and generates recommendations faster than any human can realistically review and validate the underlying data and logic.
Is the human just a rubber stamp?
That's the fear. The human might retain the authority to override, but lack the capacity to make a truly informed judgment, especially under time pressure. Unclear ROE, combined with the sheer speed and complexity of AI, can make effective human oversight incredibly difficult, intensifying all these ethical and legal dilemmas.
Okay, a complex web of potential and peril. Let's move to the final part, conclusion and way forward. Given all this, how do the sources suggest military doctrine needs to evolve?
Well, the consensus seems to be that clinging purely to traditional COI and CT doctrine is no longer viable against these threats. Militaries must move towards embracing proactive AI-leveraged strategies. But, and this is crucial, the AI needs to be framed not as a replacement for humans, but as a powerful decision support system.
Enhancing human judgment, not supplanting it.
Exactly. The goal articulated is to create an accurate, timely, and fundamentally human-focused decision support system tailored for these incredibly complex operating environments. Let the AI handle the massive data crunching, the pattern recognition, so the human commander can focus on the critical orientation, judgment, and decision-making, armed with better insight.
How do you build that capability organizationally? It's a huge shift.
The sources propose institutionalizing it. One key recommendation is establishing something like a joint interagency AI fusion cell, a JIAFC.
A dedicated hub.
Yes, a multidisciplinary team focused solely on AI and machine learning for that theater. Critically, it needs to integrate the intelligence officers, the people who understand the context, the culture, the enemy.
The domain experts.
Right. But the data scientists, the people who understand the algorithms, the data pipelines, the model limitations.
The technical experts.
Exactly. Those two groups have to work hand in glove. If they're siloed, it won't work. This cell would manage the data, develop and validate models, monitor performance, and ensure alignment with operational needs and ethical guidelines.
That's the structural approach. What about immediate mandatory safeguards, especially given the risks like bias we discussed?
3 key mitigations come through strongly. First, robust, mandatory, and auditable human-in-the-loop procedures for all kinetic actions.
Non-negotiable.
Absolutely non-negotiable. The human commander must retain clear authority and responsibility to question, delay, or veto any AI recommendation involving lethal force, ensuring adherence to IHL and ethics.
Second, tackling bias.
Head-on. Implementing a comprehensive bias testing and mitigation program. This isn't a one-off check. It needs to be ongoing. It involves regular audits, potentially by third parties, using statistical methods like SNO we discussed, but also other fairness metrics to actively search for and correct demographic, ethnic, or geographic biases in the training data and model outputs. The aim is prediction based on behavior, not identity.
And the third pillar, fixing the data foundation.
It underpins everything. The sources stress the absolute necessity of increased cooperation and rigorous data standardization among all partners in the region. ECOWAS members, G5 Sahel countries, international partners. They need agreed-upon formats, secure sharing protocols, common definitions. Without cleaning up and standardizing the input data across the board, the predictive power will always be limited, and the risks remain dangerously high. Regional cooperation is the technical and political bedrock.
So wrapping this all up, it sounds like the real challenge isn't just getting the fancy AI tech.
No, not at all.
It's adopting the whole new ecosystem around it. The updated doctrine, the specialized personnel, the integration structures like that fusion cell, and crucially, the rigorous ethical and legal guardrails.
It's a total system change.
It's about finding that incredibly difficult balance between leveraging powerful innovation and maintaining strict controls, legality, and ethical responsibility.
Precisely. It's a tightrope walk. And if we zoom out, connect this to the bigger picture.
Yeah.
The sources really suggest we're seeing a fundamental shift in the nature of conflict itself. As AI becomes more integrated into the battle space, warfare becomes less about just fighting the enemy physically and more about fighting the data war.
Interesting.
The side that can most effectively secure its own data, clean it, standardize it, analyze it ethically and rapidly, and perhaps disrupt the adversary's data. That side might gain a decisive, perhaps insurmountable strategic advantage.
Not just in the Sahel, but globally.
Potentially, yes. Information superiority powered by AI could become the ultimate high ground in 21st century conflict. Controlling the data might be controlling the future battle space.
A powerful thought to end on. That was our Fulcrum Intel Digest on AI and counterinsurgency operations in the Sahel. We certainly hope this deep dive gave you a clear, thorough, and appropriately nuanced understanding of this really complex and fast-moving field. For more expert analysis like this on global security, geopolitics, technology, please do check out our blog at Fulcrum Analytics and explore the rest of our YouTube channel. We've got previous deep dives covering a whole range of topics, from geopolitical forecasts to other security hotspots across Africa and beyond. Thank you so much for joining us. We'll be back soon with another deep dive into the information that matters most.